Hi guys, good morning everyone. Hello all. Am I audible? Is my voice reaching to all connected to responses? Okay. Hi Rajesh, good morning. All right. So we are discussing SQL queries, SQL queries we are discussing. Okay. In our last class, we have seen some basic SQL queries, some joins we have seen. Continuation with the same. Okay. We'll see some other SQL queries like, rank and case statement we'll see, and store procedure and functions we'll see. Okay, so if I say here rank as case interest, okay. So again, same, we are using AdventureWorks 2008 R2 database. We are using AdventureWorks 2008 R2 database. What it is saying, see, based upon the orders, okay, we are going to write the case statement. We are going to write the case statement by considering multiple tables from AdventureWorks 2008 R2 database. AdventureWorks 2008 R2 database. So what it is saying, generate the following if no order was done by any customer. Okay. If the order was not done by the customer, then make it as zero. And if the customer is making an order for once, then make it as one. One time for count one, regular for count range 2 to 5. If the customer has done the order uh, in between 2 to 5 times, then it should come under regular category. If the customer is making the order, if the customer has made the order between 6 to 10 times, then the customer is oftenly making the orders. And if the customer has done the order anything, let us take from one restaurant. Okay, from one restaurant you are booking the biryani, or you are booking some dessert, some favorite dish which you like a lot. So when you are booking from Zomato or Swiggy your favorite dish, so if you have ordered more than 10 times, okay, for count greater than 10 times, then you would be under a loyal customer category. If you are ordering 6 to 10 times in between, then you are coming under often customer category. If you're ordering between 2 to 5 times, then you are coming under regular. One time means okay, and zero means no order you have placed till now. Okay, to see what they are doing, what information they are fetching in the result set: customer ID, territory ID, from which place he is ordering, and total number of orders, how many he has done, and then case statement. When order ID equal to zero, then no order means when he has not done any orders, not even a single time also, then no order. When it is one, then one time. When the order is between 2 to 5, then it will be regular. When the order is between 6 to 10, then it is often. And when it is greater than 10, then the customer is a loyal customer. And the case statement and customer frequency. Okay, from this table we are fetching all this information from this customers table, and making a left join with sales order header, and making a join on top of this column between these two tables. Okay, C is table alias and O is sales order header table alias. Okay, you can give alias anything. You can give it as cust, you can give it as SOH, any alias you can give for your tables, for your columns and all. You're making a join on top of these two columns where date part, I'm saying that in the entire year 2007, for the entire year 2007, group by territory ID and customer ID, group by territory ID and customer ID. So what I'll do in order to get the result set from this query, I'll just open the SSMS. I am opening the SSMS here. Hold on. I am connecting to my local SQL server, and I'll make a connection with 2008 R2 database. Okay. Select the database, click on new query. Okay, fine. Then what I'll do, I will go ahead and I'll copy this complete query. Okay, come here and paste it. Okay, say execute. See, there are many customers. Okay, see, these are all the customers. There are almost 9,864 rows in which some customers are one-time customers, some customers are regular customers. Okay, see, total number of orders is 4 by this customer. So he is a regular customer. Some are, regular customer and one-time customer are huge, whereas frequent customers, loyal customers is not there. See, loyal customers is not there. Mostly regular and one-time customers is only there here. Okay, loyal customers would also be there, but we are going little fast here. That's why we could not able to trace it. One-time and regular customers are a lot. One-time customers and regular customers are a lot. Regular, what is the regular here? Regular is the persons, the customers who have made the order in between 2 to 5 times. In between 2 to 5 times. That is called as what a regular customer. So mostly we are having regular customers only. Loyal customers are not there. So it seems like the dish, whatever it is, the sweet or biryani or curry is not that much tasty. That's why we are not having often and loyal customers. So this kind of results we can achieve with the case statement. With the case statement, when you come up with some situation wherein you have to wherein you have to categorize the data, then you can write the case statement here, something like this. It's very, very simple, guys. Case, when condition, okay, case, and in between you can do the, okay, like when condition, then, okay, something, when this condition, then 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 something, then finally end your case statement and give the name to it. Okay, fine, guys. Very simple. Modify the following query to add a rank without gaps in the ranking based on total orders in the descending order. Also, partition by territory. Okay, so what it is saying, okay, the result in the result set, what we are fetching here, customer ID, territory ID, total orders. Always for total orders, we'll take a count. We'll take count method, dense rank. Okay, this we have done in our ADF also. In our ADF also, we have done this. Dense rank over partition by territory ID, order by count of sales order ID, descending, and then rank from this customer, making a left join with this table. This is one table, this is another table, this is left table, this is right table, but making the left join. These are the customer table aliases. Okay, joining these two tables on top of this column. This is the condition. Okay, for the year 2007, I'm fetching the data only for the year 2007 and group by territory ID and customer ID. Okay, what it is saying in the question, see, modify the following query to add a rank. Okay, without gaps in the ranking based on total orders. Okay, so what I'll do, I'll just take this one, come here, and then paste the query. Okay, see, so the customer rank, if you see here, all customers are having unique customer ID. Why? Because, okay, dense rank we have considered for sales order ID, partition by territory ID. sorry, a partition by territory ID. That's why whatever the territory ID it is, we are getting the rank generated for it, and this is how we are seeing. Okay, for every territory ID, okay, we have been given with a different rank here. That is what it is. Okay, fine guys. So multiple queries we are having. Write a query that returns the salespersons who receive the highest bonus amount. Okay, the person who has received the highest bonus amount, and calculate the highest bonus amount, percentage of total bonus amount for salesperson. Your solution must be able to retrieve all salespersons who receive the highest bonus amount if there is a tie. Okay, include the salesperson last name, first name, highest bonus. Okay, amount, percentage in the report. So first name, last name, bonus, and what I'm doing, I'm giving the bonus percentage, how much bonus percentage he has got. This is the formula. This is the formula to calculate the bonus percentage. Okay, round off bonus is the column. Okay, into 100 divided by, select sum of bonus from this table. Okay, and rounding it to two values and giving the table name alias as bonus percentage, and then generating the rank and getting all this information from this table, making a join with this table, salespersons and persons. Okay, this is the table alias, this is another table alias, making a join on business entity ID. Okay, and then select last name, first name, bonus as highest bonus, bonus percentage as highest bonus percentage from temp table. Okay, where rank equal to 1. Rank equal to 1 is 1. Why? Because the highest bonus we want, highest bonus of the salespersons we want, right? That's why we'll just come here and we'll execute this query. See guys, it will take some time for you to understand these queries, and practice only can make you understand this. Practice can only make you understand this. Okay, so the highest bonus the person who has got is, okay, retire Tesvi. Okay, retire Tesvi. Okay, how much bonus he has got? $6,700, and the highest bonus percentage is 13.78%. 13.78%. See, last name, whatever you write in the select statement, all will come in your result set. Last name we have got, first name we have mentioned, first name we have got, bonus we have mentioned. Okay, bonus we have got. Okay, and then bonus percentage, this one. This is the formula we have used, and that is what we are getting here. Okay, no, sorry, this one we are taking this, the final select statement. Last name, first name, highest bonus, and highest bonus percentage. Okay, so these are all the queries, guys. These are all the queries. Okay, that we can use to get the different types of information accordingly as per the project requirement. Okay, provide a unique list of customers IDs which have ordered both the red and yellow products. He needs a customers who have ordered both red and yellow product after 1st May 2008. Sort the list by customer ID. Okay, so what I'm doing here, see, customer ID information I wanted. That is what I have selected, and this information I'm getting from this table, making a join with this table. Okay, joining on top of this column, sales order ID. Sales order ID column is common in both. Sales order ID column is common in both sales order header table, sales order details table. Join, again we are making one more join with production dot product table, and making a join on top of this two columns product ID. Okay, then what he said he wants the customer ID for the customers who have made red and yellow products. So in condition, I'm writing here p dot color equal to yellow, and date is greater than 5th of May, sorry, 1st of May, after 1st of May, after 1st of May 2008. That's why he's saying here sales order date greater than 1st of May 2008. Okay, this is for yellow. The same we have written for red. He said yellow and red he want, right? Yellow and red he want. The same. This is for yellow. This is for a red. That is what we have written. Okay. Come this one. Okay. Copy this query. Come down. Okay. Execute this. These are the customers who has made the order product, who has made the order of the product whose color is yellow and red after 1st May 2008. After 1st May 2008. If you want, you can change the colors here. If you want, you can change the dates here. Whatever you want, accordingly, you will get the different result set. Okay. So see guys, I'll tell you one thing. See, you should not be having a very advanced level knowledge in SQL. At least if I give you this query, any query, this query or any query, you should be in a position to understand what that query is saying, what is that query is doing. If you understood that much, what is the table, how to write the syntax, where, group by, order by, having by, table aliases, column aliases, and all. If you understand that much, that is sufficient for you. That is sufficient for you, because database developers are going to work in detail. Okay, with the SQL functions, SQL queries, and all. Okay, so this is what functions we are having: SQL functions and stored procedures. So why we write SQL function and stored procedure? See here, whenever we want to, we are coming across to write the data. Yeah, that is intersect only, copy. See what I'm saying. When we write stored procedure and functions, when we write stored procedures and functions in SQL. Okay, what is stored procedure and functions? First, I'll tell you that stored procedures and functions are the artifacts of a SQL database. Okay, stored procedures and functions are the artifacts of SQL database. Okay, so when we are coming across of writing the code multiple, writing the same code multiple times, then what we'll do, we'll write that logic in the form of stored procedure, the form of stored procedure and functions, so that we need not required to write the code again and again. We need not require to write the code again and again. Okay. So see here, example I'll give you. Now my client is asking me, okay, that he need, okay, the information, okay, wherein he is expecting, see, create a function in your own database that takes 3 parameters. Okay, a function that takes 3 parameters. What are the parameters? Year, month, color. The function then calculates and returns the total sales. Okay, he needs a function that calculate and returns the total sales for products in the requested color during the requested year and month. So it is little dynamic here. It is little dynamic. What I'm saying here, I need the total sales for the given color for the given year and month. For that, what I'll do, I'll write a function. Okay, I'll write a function here. Okay. If there was no sales for the requested period, then he need that also. So what I'm going to do here, see, I'm writing a function. This is a syntax or a function. Okay. Create function, function name. Here are what the parameters I'm defining for my function. You can define one parameter, you can define 3, 4, 10 parameters, depends upon the requirement. Then returns numeric as begin. This is what all the syntax of the function. Okay, then end. This also comes, this return at sale and end will become the syntax here. This is your logic that you are writing. Okay, remaining all things are what? Syntax of your function. This is the logic. Here you are doing, you are fulfilling the project requirement. Whatever the project is asking you, that you are going to consider here in the body of the function. Okay, rest all comes under syntax. Okay, if I say here for an example, if I come here, if I say, then I'll remove this one. Okay, I'll remove this one. Now this is the syntax of your function. Okay, this is the syntax of your function. This will come always. This will come always. Okay, this is the syntax of your function. Create function, function name. This will be your function name. Any name you can give. Bracket open, any parameters you want, you can pass accordingly. Returns numeric. So I'm saying this function is going to write me a numerical value. This function is going to write me a numerical value as begin. Then here comes the logic. Here comes the logic. Logic is coming here. Okay. Here comes the logic. Okay, fine. Anything you can write accordingly as per the requirement. Okay, if you are not writing it also, fine. Okay, but at least you have to understand what is that function is writing, what is that function is returning, and all. This much you have to ensure, guys. Okay, fine. So what I'll do now, the same way, I'm defining some parameters here. Okay, to the function. These are some parameters I'm defining to the function. Then I'll declare a variable. Okay, I'll declare a variable at sales, and the data type of that variable is numeric. Okay, then what I'm doing some calculation here, and finally all this value I'm assigning it to this variable at sales. At sales, this all logic I'm defining here. Okay, this all logic I'm defining here, and I'm assigning all this to this variable sales. And if at sales is null, this complete calculation what we are doing is null, then set 0.0, else return the value whatever, return at cell, and your function and call your function. This is what calling a function. This is what a calling a function. Okay, so what is the function name here? Function name we are giving color cells. So I'll first go here and I'll check if I'm having a function already with the name as color cells. Okay, color cells is there. So I'll just first delete this function because it will throw me an error. It will say me that this function name already exists, or else you can change the function name. So I have just deleted it. I'll just take a refresh. I will remove this. I'll copy this code top to bottom carefully. Okay, what I'm saying here, using a round method. Then inside round using a sum method, unit price into order quantity. I'm rounding with two values. Okay, getting this information from this table alias, joining with one more table. Sales order header is one table, sales order detail is one table. On joining these two tables on top of this column, sales order ID, again making a join. Okay, on product table, and joining this on top of product ID, where p dot color equal to add color. Add color means what? Whatever you are giving the value for the color, for that color we are calculating. It could be yellow, it could be blue, it could be white, etc. And then for the month and year, doing the calculation here for month and year. And this is all calculation we are doing. Okay, and assigning it to this variable. And if at this variable is null, set 0, 0.0, else return the value whatever it is for the given month, for the given year, for the given color. It will give you the return value. I just say here execute. Commands completed successfully. Now how to call a function? This is the select statement to call a function. I say here select at color sales. Okay, this is our function name, color sales. So I will say here color sales function got created. I'm saying for the year 2005, for the month of August, for the color red, total sales. So for this year, for this month, for this color, what was the total sales? I want it. Yeah, so the total sales is this much for the color red. How much? 78,005, 7,85,195. You want it for yellow color? Pass here yellow. Okay, you will get some different result set. Okay, so 78 lakhs 51,000. Okay, 78 lakhs 5,195. See, it is for yellow color. No sales has happened. Means the yellow color is not there. Or might be. I'll just pass like this. Okay, no. Yellow color is not there for the month of August. If I say here for the month of September, let us say it is not coming. Okay, fine. I will say it as white color. Yeah. See, for white color, for the year 2005, for the month September, we are having 474 sales done. We have having 474 sales done. Okay, guys. So like this, now this function got saved. Yes, correct. This function got saved in our database. Whenever we want, we can consume this function. We can consume this function just by calling the function name. Select dbo.color sales. This is the details of whichever color, whichever year, whichever month you want as total sales, whatever the name, alias you can give, and you're getting that result set here. This is the beauty of a stored procedures and functions. You need not require to write the code again and again. It will store in the form of an artifact in your database. Stored procedures and functions, guys. Getting? Yes or no? Next, see what it is saying. Write a stored procedure. This is a stored procedure in your own database that accepts two parameters. First is the starting date, then the number of consecutive dates beginning with the starting date. Okay, number of consecutive dates beginning with the starting date. The store procedure then populates all columns of the date range table according to the two provided parameters. See, firstly, if there is any stored procedure with this name, I am dropping that stored procedure. Standard practice. If there is any stored procedure with this name, this is the table name. If this any table as such with this name, in advance, we are deleting that table. Then drop procedure. If there is any procedure with this name, dropping the stored procedure, just to be on safe side. Okay. Then this is the syntax of the stored procedure. What is the syntax of stored procedure here? See, I'll just show you. Syntax of stored procedure is very simple. Okay. What I'll say, create procedure, procedure name. This is the parameters we are defining. This is all logic we have written. See, this is the syntax of stored procedure. Create procedure, procedure name, and these are the parameters that you are defining. This is also optional. If you want, you can pass accordingly as per the requirement, as begin end. That's it. This is the syntax of stored procedure. Now, in between what you are writing, all these things, in between what we are writing, all these things, this is called as what? A logic. This is called as what? Code, wherein you will change this accordingly as per the requirement. And the parameters also I'm giving as per the need. So now, what I'll do, I'll just take this complete procedure. Okay, I will paste the complete procedure. See, create procedure, procedure name. Okay, procedure name. I'm defining two parameters here. Okay, start date, number of dates. Because why? It has given me here in the requirement. He needs a start date and he need a number of consecutive dates. That's why I'm defining two parameters here, as begin, part of stored procedure, and I'm defining a variable here. Okay, at counter, and that data type of the variable is int. So initially I'm setting this variable value to 0. Then while I'm saying, while at counter at this variable not equal to number of dates, then I'm defining one more variable, insert the date, and data type as date here, insert date, date add, insert into this table, date range, values at insert date, this variable that I have defined here. Okay, I'm saying date part for year, quarter, month, and day, week. Day, week. Okay, set at counter equal to at counter plus 1. Just increase it with one value plus 1. Okay, and your begins. Okay, while, and then this is end for your store procedure. This is done. So if I say here store procedures, see this folder. If I expand this one, what is the so populate date range? Okay, populate date range store procedure is there. I'll delete this, else I'll get an error. A store procedure with this name already existing. That's why I have deleted. I'll take a refresh. Okay, now I'll go ahead and declare I'll create this store procedure. Okay, not find store procedure T. What is this store procedure T? 1 minute. No, it is not there. It is saying that the store procedure is already there. Yeah, now it is completed. Okay, it was not get refreshed actually. Command is completed successfully. This is good. So what I'll do now, I will execute the stored procedure. How can I execute the stored procedure here? See, this is a stored procedure. Okay, and I'll say here, select star from dpo.rate range. This is the table, and this is the execution of stored procedure. Okay, so let me check what is happening with this table. Okay, date range is one table. We'll check. Yeah, we are having some dates in this date range table. Okay, populate date range. I'm asking for this year, for this month, for this month, for this date. Okay, and day of the week is, and see, start date, number of dates for 10 dates. This is start date, number of days. Okay, okay, so it is showing that something like this. Okay, 2024 3 4, today's date 4th of March. A12 and all, it is just giving and it is giving 10 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 rows. Okay. For this year, for this month, for this date. Okay. Fine, guys. This is what how it is. Using an adventure works database, create a function that accepts as customer ID and returns the full name. What it is saying, write a function that accepts the customer name. Accepts the customer name means very clearly we have understood that it is going to having one parameter and customer ID accepts a customer ID and returns the full name. So it is going to take customer ID and it is giving you the customer name. And that customer name it is going to return you by taking the customer ID, and that customer name is having both last name and first name. Write a function, very simple. Okay, see, customer ID should accept means parameter we are defining, and then full name we are declaring as variable. Okay, we are saying last name plus first name because it has been asked. The columns we are fetching from persons table. Okay, persons table. How can I say from persons table? Because the alias for persons table is P, and we are calling that column with P dot last name and P dot first name. Okay, joining these two table, customers and person, on top person ID and business entity ID, where C dot customer ID equal to at customer ID, whatever the customer ID that user is passing to my function. Okay, then return the full name and the function. Okay, so I'll just take this one. Okay, I'll just come here. I'll take a new query. Okay, I will just come to functions here. Is it I'm having full name, get full name. So this function already I'm having get full name. I'll just say here 1515. You can do like this also. Okay, just to change the name or else delete the existing one and create this one. No problem. Execute, commands completed successfully. Now what I'll do, I'll say for this customer 29487, for this customer ID, what is the name that I'm going to get it? Okay, I'm going to get it. See, for the customer ID 29487, the customer name is okay, Humberto. Acevedo Humberto. Okay, if you want for other customer name, then you have to change the customer ID. So first you have to get the customer ID here, then pass the customer ID, then you are going to get the customer name. Okay, so what I'll do, I'll just come here. Okay, let us see what are the different customer IDs we are having. Okay, select star from okay 2008 R2 database. If there is any table with customer name, yeah, dbo.customer. Okay, dbo.customer. Okay, okay, is it not taking from here? I think it is not taking from this table. From which table it is taking, Baba? Acha, sorry, sales.customer. This is the database object. Sales.customer it is. Yeah, this table. Okay, sales.customer. Okay, I'll execute this one. Yeah, see, these are all the different customer IDs I'm having. If I say here for customer ID 61, just pass here 61, then we'll see what we'll get the customer name. Null. So far, 61 customer, the customer ID is not there. Okay, so I'll give some other number, 3011. I'll say here 3011. Ayo, what is this? Why we're not getting the value for any of the customer ID? 28317. Am I passing the correctly or not? Yeah, I got it. See now? Yeah, might be there is the case. Okay. Acha, it was 111. Okay, sorry. So might be definitely for some customers it is different. It is null, but for some customers, the customer ID, if you pass, you are going to get the name for that customer. You are going to get the name for that customer here. Okay. Fine, guys. This is how we write the store procedures, functions, triggers, and all that stuff. Okay. This is triggers we are having. These are the triggers we are defining here. See, trigger. Okay. This is trigger, I believe. Okay. Write a trigger to put the change date. Write a trigger to put the change date and time in the last modified column of the order table whenever an order item in sales order is changed. Whenever an order item in sales order details table is changed. Okay, whenever an order item is changed in sales order detail, then he need the details. So we are creating three tables here: customer, sales order details. Okay, and then we are writing the store procedure here. Okay, if there is a store procedure with this name, then in advance we are deleting it. That's it, nothing more than that. Create trigger. This is the trigger name on this table. I'm creating a trigger on this table. Okay, sales order details after insert update delete. This is the procedure of the syntax of the trigger. This is the syntax of the trigger. As begin, declare a variable. Okay, so this is the logic that you are going to write and end your trigger here. End your trigger. Okay, that's it. Now what will happen? This trigger will get initiated whenever this condition met. Whenever this condition met, automatically your trigger will get initiated. Triggers will not work. You will not work on triggers. No need to worry. The maximum that you work upon is, okay, SQL queries. Okay, plain SQL queries. Okay, you will work upon, okay, as an Azure data engineer, and you can also work on stored procedures and functions. Okay, plain queries means many things comes here. In plain queries, many things comes here, like, where clause, okay, aggregate functions, group by, having by, subqueries, joins, okay, left join, inner join, all that stuff will come here. Okay, see guys, if you want very, very, very basics of SQL, okay, absolute basics of SQL, then you can refer this one, W3 schools, okay, or SQL. Okay, this also you can take. This is going to help you a lot, especially for the people who are very, very new. This is absolutely from the start of SQL. Select statement, what is select distinct, what is where, order by, and when to use and operator, when to use or operator, what is not, what is insert into, what is null values, update, delete, select top, minimum, maximum, count. All this will get it here. Every single thing you are going to get here. See, this is absolute basics of SQL. Very, very, very basics. Okay. I'll give this article. Okay. I'll give you this article. You can practice it, guys. Okay. Lata, what you are saying, ma? Query file, please. Which query file you want? This is already a GitHub. This is already all in GitHub. All these queries are in GitHub. Okay. So this complete GitHub query I have attached here in the material at page number 169. You will get it. Just open that. Yeah, this one, na? This file you are asking, na? Okay, I'll paste it here. That's not a problem, but I'm telling you the correct way to go. Okay, in the material what I have given you, in that material page number 69, 169, go to page number 169, open this one, you will get all this, not this one file. You will get all these files. Okay, you can just go here and then you can click on it. You will get that files here. Okay, getting fine. Okay, and also W3 schools also have given. This is for very beginner, absolute beginner. The people who are not from IT background, they have not read any subject of computer science in their engineering. They are not from computer science background, like from sales or from electrical mechanical background. For them, they can refer this. See, guys, you have to work hard. Believe me, you have to work hard. I am working very hard even after 14 years of experience also. So now you can imagine nothing you will get just like that in this world without your efforts. Believe me, trust me. Okay, fine. This is what we are having multiple SQL queries, guys, with different concepts here that we have discussed. Okay, so I request all of you to refer this SQL queries. We are having others also, but I don't think that we are going to use it. Okay, create database and database tables and all this. See here, we are creating the tables. This is very simple. Create table, table name, column data type, identity. This is the constraints. We are having multiple constraints in SQL, guys. What is constraints and all? If you want, you can see it here. See, SQL constraints. SQL constraints are used to specify rules for data in a table. It is used to specify the rules for the data in a table. Constraints can be specified when table is created with the create table statement. After the table is created with the alter table statement. See what I'm doing here. Create table, table name, column data type, and column constraint. Column name, column data type, and column constraint. This is what I'm saying here. Okay. This is all theoretical information. That's why I told this W3 schools is very helpful for the beginners. Okay, SQL constraints are used to specify the rules for the table in a table, are, are used to specify the rules for the data in a table. Constraints are used to limit the type of data that can go into the table. Okay, it can limit, it can restrict. Okay, like how traffic rules will restrict us to drive properly on the road. Correct na? Traffic rules, what it will do? Speed breakers is there, zebra crossing is there, red signal, green signal is there. These are the rules that will ensure that we are driving the car or the bike in a very proper manner. The same way, constraints will help us to insert the correct and proper data inside the tables. Inside the tables here. Okay, fine. So this ensures the accuracy and reliability of the data in the table. If there is any violation between the constraint and the data action, the action is aborted. The action will be aborted. Constraints can be column level or table level. Column level constraints apply to column, and table level constraints can be applied to the whole table, the complete table. The variety of different constraints we are having is what? Not null constraint, unique constraint, primary key constraint, foreign key constraint, check constraint, default constraint, create index. Create index. Multiple constraints we are having, and every constraint is having a unique functionality to do. Every function is every constraint is having a unique functionality to do. Like your eyes functionality is to look, your hand functionality is to do the work, to write, to eat, correct? Your nose functionality is to smell. In the same way, different constraints we are having: not null, unique, primary key, foreign key, check, default, and all. Every constraint is having some unique functionality to do in the SQL tables. That is what they have mentioned here. Okay, fine guys, correct or not? So if you come here, that is what it is saying. Okay, create table, table name, column data type, identity, constraint, not null, one constraint, and primary keys and another constraint. Okay, column name, data type, not null constraint. Column name, data type, not null constraint. Column name, data type, not null constraint. Okay, then these are multiple tables we are creating with some constraints. Okay, these are all the column names. These are the column data types. These are all the constraints. Create table term, column name, data type, data type, data type, and then constraint. This is the constraint, not null, not. Not null means what? When you are inserting the data into this term table, then you cannot pass here null values for the year and term, because we are mentioning a not null. It will not allow you to insert the record until and unless you pass some values here for the year and term columns. Please understand, that is the functionality of constraints. Okay, next we are having create table, table name, course, course ID, column name, data type, identity, not null, primary key. Okay, identity means a unique value will get generated. Not null means it will not allow you to insert something null without passing anything. If you're trying to insert a record into this table, that is not possible. Primary key is what? Primary key is means the data will get inserted in a sequential order. The name, description, column name, this is data type, this is the constraint. Okay, multiple tables here we are creating, guys. Multiple tables here we are creating. Okay, so this W3 schools is going to help you a lot, guys. Lot of things are there here. Lot of things are there. Okay, see, aggregate functions also we are having here. Minimum, maximum. What is minimum? What is maximum? Okay, if you want, you can try it yourself. Try yourself. Try select a minimum price from products table. Okay, select your run query. So see, you are getting the minimum price is 2.5. This is the least price. If I say here maximum, then you will get the maximum price. Just try this, guys. Explore this. You are going to learn a lot. Okay, in my initial career, I have used this. Okay, W3 schools to learn. See, if when I change here the formula to max instead of min, so it is giving the maximum value inside the table is 263. Like this, you can do many exercises and you can learn, guys. Okay, this is very helpful. This is very helpful for you. Okay, count, sum, average, like, wildcard characters. What is in between, aliases, joins, inner join, left join, right join, full join, self join. Anyhow, joins I have explained very well. Okay, having, when to use having, what having will do. Having clause was added in to SQL because the where keyword cannot be used with aggregate functions. Where we cannot use with aggregate functions. Now to use the aggregate functions with filter, we have to use with, we have to go with having clause. Okay, this is the demo table. This is the syntax or query you are writing here. Basically is query. Customer ID, count is what? This is aggregate function. Count, sum, minimum, average, maximum, these are all the aggregate functions. So whenever you are using aggregate function in your select statement and you want to filter the data or result set on top of the column in which you have used the aggregate function, then you have to use having clause. Practice, guys. Practice, you will get it. Practice, you will get it. Okay, all these things I've given here. If you want, I'll just add this in the material also. Okay, I'll just add this here in the material as well. Okay, I'll just add this as a second link. Okay, fine. If I open this one, yeah, this is what I'm going to get. Fine, guys. So this is what SQL queries that we have discussed, guys, in last 2, 3 classes. Fine. So what I'll do in our next class, I'll show you, I'll start with okay, Synapse Analytics. What is Azure Synapse Analytics? What is Stream Analytics? This I'll start. Okay. And there is one more concept I'm going to show you. What is that concept is how we can run this. One more concept I'm going to show you, how we can run the okay SSIS packages. Okay, SSIS package from Azure Data Factory. This concept I'm going to show you. This concept I'm going to show you. Either I'll show you tomorrow or else I'll show you in the later classes, maybe after 2, 3 classes, whatever. Okay, how we can, run, sorry, how we can run or execute the SSIS package from Azure Data Factory. Okay, this also I'll show you. This SSIS package will be in our laptop on-prem. This will be in our on-prem, and Data Factory is Azure Data Factory is in our cloud. This also I'm going to show you guys. This concept also I'll show you. Mostly I'll try to show you this in tomorrow's class. Okay, Synapse Analytics I'm going to show you. Use Stream Analytics I'm going to show you, Lata. Okay, so this is the material that I'll share it across. Okay. No, Lata, Cosmo DB we are not covering. Cosmos DBs we are not. See, guys, I'll tell you one thing. Okay, there is no end for any technical field, for any technology, there is no end. Believe me, guys, believe me. If you work in a project, let us take Azure Data Engineering. If you work for 10 years also, you cannot say you are perfect now in that technology. It will just keep on coming and coming. So what we'll do here, as per the project need, as per the requirement of the project, we keep on learning new things. Okay. Yeah, Yashwant, I'm going to provide lot of POCs. Module wise, Yashwant, I'm going to provide POCs. That POCs is a kind of a mini project, I can say, wherein you have to read the requirement and you have to do the labs. You have to do the labs. I'll give you at the very end of the classes, this all things. Okay. What is this, Shalini? Sir, the document we have is only until 50 pages. Will you share this with us? I have not shared the updated document with all of you. Okay, no, I think I have shared it, Shalini. You have not downloaded it. I believe so. So hold on. I'll upload it one more time. I think you are absent that day, or I'm not sure what it is. Correct, now, guys? I have not. Okay, 1 minute. Hold on. I've just added some theoretical content. Okay, I'll just go here. Azure Data Engineer. Okay, I'll just say here file upload. I'll say here Azure Data Engineer study material updated. From here, and I will. Okay, see, guys, I'm sharing this Google Drive link. Please download, everyone. Everyone, please download it. Everyone, please download. Okay. See, DP203 Azure Data Engineer study material updated. This one. Okay. Please download this material, everyone. Okay. I'll keep this. I don't delete. No need to worry. Okay. Fine. Just hold on for some time, guys. Hold on for some time. I'll share it with everyone here individually, one by one, one by one. Okay. So next week, definitely, I'll not next week, this week only. By the end of this week, Harsha, I'll just share it. I'll share it across. Normally, I'll share it. Even if you won't ask, also, I'll share from my end. For every batch, I'll share it. But I'll share at the end of the batch. Still, the batch is not finished for us. Okay, at the end of the batch, I'll share it. What I suggest you guys, more than the interview question and answers, please read this material. What all the material that we have referred through, please read this material thoroughly. If you read this material word by word, then believe me, this is also more than sufficient for you to crack an interview. To crack an interview, see, these are all the topics. These are all the topics. See how many topics we have discussed. See, infinite topics we have discussed. If you are thorough with these topics also, see how many topics are there. Oh my God. Then this is sufficient for you to crack the interview. I'm telling you. Getting definitely I'll share, ma. I'll share. Okay. Normally my practice, my procedure is to share at the very last classes, like just second last class like that. I'll share it. No worries. Okay. Please read this material. This material is more important. Interview question and answers is what? Just you mug up. That's it. You just mug up. But here we have done each and every lab. Here we have done each and every scenario. Here we have done lot of examples and all. If you read this, if you do these labs, this will give you a different level of confidence for the interviews point of view. Okay. Fine. All right, guys, I'll just close the class for today. Tomorrow, we'll see SSIS integration with Azure Data Factory, how we can execute SSIS package with Azure Data Factory. Then we'll go with Azure Synapse Analytics. Then we'll go with Azure Stream Analytics. Okay. Then different concepts are there that we'll cover. Okay. Bye, guys. Bye, everyone. Thank you. Take care.